my name is Ben, and as Rebecca said, I am a consultant here in the New York office of FSecure. A lot of what we handle in the New York office is application security, be that web application or mobile applications. We basically take on the role of the attacker to attack a particular application to see what we can make it do. And you've heard a couple of talks today from people who are on the network side of things, and how they go about attacking networks, and a little bit about how detection and response has started to become a focus in the network area and really in security as a whole. But one thing I have noticed in my work with application security is that application security doesn't really seem to have caught up on this focus on detection and response. We're still very much focused on the prevent mindset. I will say that in my experience, I've talked to a lot of consultants who have been on a network penetration test and have been detected and had their attacks stopped by the client. But I can't say I've ever heard a similar story with an application security assessment. Pretty much, I can go on site, I can start attacking your application, and no one will know what has happened until I hand them the report. And this is a problem because a lot of attacks do originate out of attacks on web applications. According to the Verizon Data Breach Investigations Report, about 25% or so of breaches, successful breaches, start at a web application. So that's more than any other category that Verizon is tracking. Really, this kind of speaks to a lack of detection and response tooling that is focused directly on application security. And so I would like to come to you guys today to propose a potential solution. And that solution is an attack-aware application. So to give you a bit of an overview of what we're going to be talking about, I'm going to start off by telling you what I do as an attacker and how an attacker will go about attacking a web or mobile application. I will then go into talking about what an attack-aware application is, how it can help solve some of these problems. I'll explain how developers can implement these features in either new applications or in existing applications that you already have deployed in your environment. And I'll talk about some of the benefits to doing so. So pretty much every attack against an application comes in 3 phases. The first of these phases is vulnerability discovery. At this point, the attacker has pretty much no idea what your application does or what it may or may not be vulnerable to. So their techniques are going to be basically to throw whatever possible exploits they can think of against the wall and see what sticks. As an attacker, I might try to find all of the inputs on your website and try to attack them with SQL injection or cross-site scripting. I'll try and upload malicious files. I'll try using directory traversal to access files I shouldn't be able to. I will basically try anything that I can think of and see how the application responds. And I'll be looking for things like error messages or maybe like seeing pages that I wouldn't expect to see, maybe some strange behavior on a page. And from that, I will get a general idea of what potential flaws could exist in the application. From there, I'll move on to exploit development. And in exploit development, we have a general idea that, okay, maybe this application might be vulnerable to SQL injection due to some of the behavior I observed in the previous phase. So now I'm going to try a bunch of different SQL injection payloads to see, first of all, if it actually is exploitable. And second of all, if it is exploitable, what are some of the limitations? Are there certain characters that are being filtered out that I have to work around? Are certain SQL functions not available that I might have to work around? Once I have a pretty good idea of what the application might be vulnerable to, I'll move on to the final phase, which is exploitation. And exploitation is where I take all of the information that I have just gathered and I craft a specific exploit to do a specific malicious thing within the application. So in this example, I would use SQL injection to create an administrative user on the SQL server. Obviously, a bad thing to have happen. So the three phases, vulnerability discovery, exploit development, and exploitation, pretty much comprise any attack against any application that an attacker would have access to. The problem is that most detection and response tooling really only looks at your application from the perspective of the server or from the network. So it'll definitely pick up the fact that an admin user has just been added, but it won't pick up any of the stuff that comes before. My question really is, why would we wait to respond when an attacker has already succeeded when we could be detecting and responding to their initial failed attacks? And that's exactly what an attack-aware application does. An attack-aware application is an application that is able to detect failed attacks by attackers and respond to them before they succeed. For those of you who think in code, here is an example of what a traditional versus attack-aware application might look like. Go, magic circle, go. Oh, that's not the magic circle. Magic circle, no. Okay, all right. So in the traditional example, we have here basically an input validation. We'll take a look at our user's input and see if it is valid. We'll see if it matches what we believe that a user's input should be. If all is well, then we're going to respond to them as if they were a normal user. But if we notice that something might be wrong here, we'll just reject their request, and that's about it. The problem with this approach is that an attacker can just try again. Just because you were able to catch them the first time doesn't mean that you're going to be able to catch them every single time. And if there is even the slightest flaw in your validation code that an attacker can figure out, they will just keep trying until they find it. An attack-aware application acts a little bit differently. We still have the same general framework of we're going to see if the user's input matches what we expect, and if not, we'll reject it. But it's not just that we're going to reject it. We're also going to take a note of it. We're going to try and identify who this person is. We're going to try and identify where they're requesting this from, what kind of browser, what kind of operating system, any information we can possibly find, and we'll make note that they have done something suspicious. If we see a pattern of suspicious behavior from an attacker, then we know they are in fact an attacker, and we need to respond to them accordingly. And to give you an idea of how that might actually happen, I'm going to go into a little bit more of a visual example. A question? So excellent question. So most applications will have some type of input validation to begin with. They'll have some amount of checking to make sure that a user's input matches what you would expect for a particular data field or input in the application. If we notice that a user is submitting lots of requests that are malformed or lots of requests that, that trigger our input validation code, then we can start to become suspicious of them because they are submitting input that we don't expect. And if we actually are able to recognize that input as malicious, like in an example that I'm going to go into in just a couple of slides, then we'll start to be able to respond to them. So. Yes, and so if you, I will actually be getting to that in just 1 second, so if you just hold off for just 1 minute, and if I don't answer your question, then be sure to interrupt again. So here's an example of how this might work. So let's say we are running a search engine, and that search engine is a search engine for images. Let's say our user searches for an apple. This is a happy case. We know what an apple is. We're going to display them an apple. Nothing has gone wrong so far. Now our user tries a slightly different input. They're going to search apple or 1 = 1. This is an example of a very, very basic SQL injection attack. So presumably our application is at least a little bit robust against SQL injection. So we will catch this as a malicious input and filter it out. Now, what we actually do with this information varies depending on whether we are running a traditional application or an attack-aware application. In a traditional application, we're taking a purely whitelist approach. So if our input matches what we expect, then we will respond to them. Otherwise, we will block the request, and that's all we do. So in this case, our input validation code was triggered. We block the request, and then the attacker is free to try again. In an attack-aware scenario, we'll use a combination of a blacklist and a whitelist approach. So just like before, we'll notice that the input was invalid, and therefore we'll block the request. But we'll also be checking against a blacklist of known strings that are reminiscent of an attack. And how this exactly works is, I'm kind of glossing over here, to be honest, but different types of attacks have different characteristics. So if you notice things that look like SQL code within a user input, then you can be fairly confident that the person is attempting SQL injection. If you notice script tags, it might be cross-site scripting, so on and so forth. So once we've noticed that our user is making a malicious input, we're going to mark them as a potential threat, and we're going to respond to them differently than we would a regular user. So there are a couple of options of how exactly we might do that. A very simple example would be we could just block the attacker from accessing our application anymore. We can say, OK, you have tried to attack us, therefore we don't want to serve you anymore, so you're blocked. This is a very simplistic approach, but it would, in fact, deter the attacker. A more nuanced way of doing this would be to set up a UAT or testing environment that is sandboxed away from your regular production environment. And if you notice that someone is acting suspicious, that they're acting as an attacker, then you can just kind of silently redirect them to your sandbox environment. From there, they're free to attack as much as they want because none of your production data is at risk, none of your production systems are at risk. But you now have an attacker who is attacking a sandbox environment, and you can log everything that they're doing and see everything that they're doing. And if they do happen to succeed at attacking your sandboxed environment, then honestly, that's great. Now you have data of an attacker successfully breaching your application, but without actually causing any harm to your business. You can give this information to your developers, and they can then fix the flaw that the attacker just exploited in the production environment. If you don't want to spin up an entirely separate environment, another thing you might want to do is respond to all of the attacker's requests with static content. So in our previous example, we could say, OK, we noticed that this person was an attacker, and the last thing that they searched that was valid was an apple. So let's just send them a picture of an apple no matter what they ask us for. And in this way, the attacker's not even hitting our database. They're not even going through any of our application's input validation or logic. They're just getting the same static response every time. Now, a smart attacker will eventually figure out that this is what's happening, but you can still gather a bit of data on what types of techniques they're trying in the meantime. And you might get a better idea of what their techniques are and what their goals are. And alongside any or all of these behaviors, you can also alert your security operations center to make sure that a human is actually monitoring and looking into what this attacker is doing, so that in the case that something goes wrong, you have someone already on the case monitoring this. Did that answer your question?
Yeah, to a certain extent. So, say that attacker has the credentials already. Right?
Sorry, could you repeat that?
Attacker has the credentials already, right?
OK, yeah.
He's not come as you. Now, he's a legitimate user, but you do not detect that scenario.
Yeah.
He tries to do some people injection time.
Yeah.
You kind of tag him as a potential threat, right? Or
So If I'm understanding your question correctly, if a legitimate user with legitimate credentials suddenly decides to start attacking your application, the question is, what can you do then to detect them? Is that correct? So we're evaluating each one of these users' inputs independently, just like we would in a traditional application. The difference here is that once that user starts attacking us, then we can start marking them as an attacker. Their prior behavior doesn't really matter to us. Once they become malicious, once they start attacking us, then we know that we want to respond to them as if they were an attacker.
But then you're attacking a legitimate user, when the legitimate user is not really an attacker. You understand that? So if a legitimate user
Yeah.
logs on, you might treat him as an attacker and send him to the sandbox. So how do you detect that from that?
So you mean if an attacker is attacking a legitimate user account, correct? Okay.
I'm basically manipulating your system.
Yeah, I understand what you're going for. And we are not just looking at what account the user is signed into, but we're looking at a bunch of other factors, including their browser fingerprint, what operating system, their IP address, so on and so forth. So it's not just the user's account, but a lot of other factors. And I'd be happy to talk with you more about this after the presentation.
Thanks.
So another example here that might ring true for a lot of people in the room today is credential stuffing. So credential stuffing is an attack type that has gained quite a bit of popularity recently and has hit quite a few financial organizations. It is essentially a variant of a brute force attack. Whereas in a brute force attack, an attacker will try and log into one user account with a large number of common passwords. Here, our attacker will log into a large number of user accounts with one common password, or with passwords that they have retrieved from a database breach or a prior data dump. So this can be hard to detect sometimes because in the traditional approach towards defending against brute force attacks, we're looking at a specific user and seeing whether or not that user has logged in a certain number of times. So, for example, we could have a lockout policy where after 5 invalid attempts, we'll lock a user's account for half an hour, let's say. And that will definitely stop this first type of a traditional brute force attack. But in credential stuffing, that's not really going to do much good because the attacker is only logging in once per user. So it's kind of hard to determine whether they're attacking or not. In an attack-aware approach, we'll look at something a little bit different. So we're going to try and detect failed logins from the same source. At this point, we're not caring about what account they're trying to log into. We're caring about data like their browser fingerprint, their IP address, where in the world they're located, things of that nature. When we're detecting multiple failed logins from the same source, let's say for an example threshold, we'll have an attacker attempted 10 invalid logins on 10 different user accounts. From this point onwards, we're fairly confident that this person is not legitimately trying to log into these accounts. They are probably trying to attack us, or they're probably trying to attack these user accounts. So what we can do is knowing that fact, we can respond to every single login request from that same source as if it were a failed login attempt. So we'll just tell them that every password they try is invalid. Once that has happened, we can even go a little step further and see if the credentials that they entered were valid, then we can alert the legitimate user that someone has tried to log into their account with legitimate credentials. And we can either just alert them, we can force them to change their password the next time they log in, or we can lock out their account entirely and have them contact our customer support with another formal identification, depending on how high assurance the application is. So this will block both the first type of attack and the second. So this is probably a more robust approach to brute force types of attacks. So we've seen some of the benefits of attack-aware applications on security specific applications. So let's take a look at how exactly we go about implementing this into both our existing applications and any new applications that we are developing. So I told you at the beginning this was a detection and response talk, but really the first step here is still prevention. We still have to be able to identify those initial attacks, those initial vulnerability discovery and exploit development attacks in order to be able to detect that someone is an attacker. Attack-aware applications detect attackers, not vulnerabilities. So it's not going to replace your need for things like input validation or authorization checks. Once you have those kinds of basic security controls in place, though, then you can move into detection. You can identify key security controls within your application, things like input validation, authentication checking, authorization checking, error handling, direct object references, things of that nature. And in the parts of the code that implement these security controls, you can add detection points that will alert when the code is triggered. So in this way, you'll know who is triggering your input validation code, who is triggering your authorization code, and who is basically causing errors within your application. And from there, you can build up a model of who is a legitimate user and who is an attacker. Once you have this basic detection, then you can continue to improve on and iterate on it by having various different sources attack your application and see whether or not you detect it. For the first stages of this could be something as simple as a web application scanner or even just a QA tester who goes through common attack patterns and sees if your application is vulnerable to them and if you can detect them. But ideally, you would work with an actual pen tester who does this kind of stuff all the time and really knows how the attackers are attacking your application and seeing if you can detect what they're doing. Once you get to that point, then you will end up with robust detection capabilities and also robust security controls because now you've had all of these attackers try to get into your application and actually detected when they succeeded versus when they didn't. From that point onwards, you can start building up response capability based on the requirements of your application and of your business. And if you'd like a more concrete example than this, the Open Web Application Security Project, or OWASP, has developed a project called App Sensor, which provides a number of reference implementations of attack-aware applications, which developers can look at to get an idea of how these applications are built and what kinds of features are being used there. It also can help with, they have a lot of guidance on where exactly to set thresholds for attackers versus just suspicious input. So once you implement these types of controls and these types of frameworks into your applications, you'll start to see a lot of the benefits very quickly. First and foremost is that you will be able to detect attackers faster when they're attacking your web applications. You'll detect them while they're still trying to determine whether or not the application is vulnerable, not once they've already succeeded. Once they've already succeeded, it's a little bit too late. They're already on your network. They're already in a position where they can do something like what Jock mentioned and start mapping out your environment and start launching further attacks. If you can stop them before they get to that point, then you're golden. They can't get that initial foothold and they can't launch their further attacks. And if you do something like the Sandbox environment that I had mentioned earlier, then you can actually give your developers a chance to fix vulnerabilities as soon as the attackers find them, because the attackers will find them, exploit them, and then presumably eventually realize they're in a sandbox, but have no real way of breaking out of that sandbox. So your developers can then fix those vulnerabilities in the production environment before the attackers actually get a chance to exploit them. Another benefit you'll get is increased visibility into your application security. Once you identify an attacker, you can study what they try and do against your application and use that to inform future security decisions and inform future vulnerability fixes that you implement into your applications. You'll also get a better idea of who is attacking you, even if they fail. It's very helpful to know that someone has attempted to attack your application and failed, because that means they might come back later armed with more knowledge or more experience. And the final benefit, which I feel like is underplayed a lot in security, but I feel like is really important, which is developer morale. So a lot of times when developers interact with security teams, they're basically just handed a big report full of vulnerabilities, which essentially translates to a big report full of things they have done wrong that they need to fix. And it's not very common that a report will include all the things they've done right, all the things that have been done well, all the times that the pen tester or the attacker has attempted to attack their application, failed, and had to try something else, had to get more sneaky or crafty. So having visibility and celebrating the successes of your security team and celebrating the successes of security within your application can really help foster a culture of enthusiasm about security rather than dread. Seeing a report with 20 vulnerabilities looks really bad, but at the same time, seeing a report with 20 vulnerabilities and seeing logs of 100,000 failed attacks, it makes it seem a lot less hopeless for the developers. It gives them a better chance of saying, okay, well, we stopped them all these times, why can't we stop them here? So in conclusion, I started off with the premise that off-the-shelf detection and response tooling is insufficient for application security. And really, I think that the main reason for that is every application is so different. You can't just bolt something on top and expect it to fully protect you. The people who are best suited to protect your application are the developers of that application. They know it better than anyone else, and they know where things can go wrong. So giving your developers the tools that they need to defend these applications and to really see and gain key insights on where the vulnerabilities may lie and what attackers are actually doing to attack them is hugely valuable in developing the security posture of all of the applications that you've deployed across your enterprise.